Chapter 2, Active Directory Domain Services. Welcome back. In the previous chapter, we explored the overall architecture of Active Directory and learned how domains, forests, and trusts fit together. Now it's time to go deeper and examine the engine that powers the entire environment. Active Directory Domain Services, often referred to as ADDS. When administrators talk about Active Directory, they're usually referring to AD domain services. This Windows Server role is responsible for storing directory information, authenticating users, authorizing access to resources, and replicating information across domain controllers. Understanding ADDS is essential because nearly every Active Directory task ultimately depends on these core services. In this chapter, we'll explore four critical components: the Active Directory Database, AD Integrated DNS, the Global Catalog, Active Directory Replication. Together, these technologies form the foundation of every Active Directory environment. Section 1, the NTDS.dit database. Let's begin with the Active Directory Database. Every domain controller stores its directory information in a database file called NTDS.dit. By default, this file is located in the Windows NTDS folder on the server. Think of NTDS.dit as the heart of Active Directory. Every user account, computer account, security group, organizational unit, and many other directory objects are stored within this database. Whenever an administrator creates a user, resets a password, joins a computer to the domain, or modifies a group membership, that information is written into NTDS.dit. The database uses Microsoft's Extensible Storage Engine, commonly known as ESE. Rather than writing changes directly into the database, Active Directory first records modifications in transaction logs. Only after the transaction has been safely recorded are the changes committed to the database itself. This design significantly improves reliability. If a server unexpectedly loses power during an update, Active Directory can replay the transaction logs during startup and maintain database consistency. Inside the database, information is organized into several partitions. The first is the domain partition. This contains objects that belong specifically to a particular domain, including users, groups, computers, and organizational units. Next is the Schema partition. The schema acts as the blueprint of Active Directory. It defines what types of objects can exist and which attributes those objects can contain. For example, the schema defines what a user object is and which properties, such as name, email address, and department, are available. Because the schema must remain consistent throughout the forest, it is replicated to every domain controller. Another important partition is the configuration partition. This contains information about the overall Active Directory infrastructure, including sites, services, replication topology, and forest-wide settings. Like the schema, it is replicated across the entire forest. Finally, there are application partitions. These are commonly used by Active Directory integrated DNS zones and allow specific information to replicate only where it is needed. One of the strengths of Active Directory is scalability. Modern Active Directory environments can support millions of objects in extremely large enterprise deployments. This scalability is one reason Active Directory remains a core identity platform for organizations around the world. Section 2, Active Document Integrated DNS. Now let's talk about DNS. Many new administrators think of DNS as simply a system for resolving names into IP addresses. While that's true, DNS plays a much larger role in Active Directory. In fact, Active Directory has a direct dependency on DNS. Without properly functioning DNS, users cannot locate domain controllers, computers cannot authenticate, and many Active Directory services will fail. When a user logs into a domain, the computer first needs to discover an available domain controller. It does this by querying DNS. The recommended deployment model is Active Directory Integrated DNS. In this configuration, DNS zones are stored directly within Active Directory rather than in separate text-based zone files. This provides several major advantages. First, it allows secure dynamic updates. Only authenticated domain members can register and update their DNS records. This reduces the risk of unauthorized systems modifying DNS information. Second, DNS data benefits from Active Directory replication. Every domain controller running DNS can maintain a synchronized copy of the zone. This improves availability and fault tolerance. Third, Active Directory automatically manages critical service records. These special records are known as SRV records. SRV records allow clients to locate services within the domain. For example, when a workstation needs to locate a domain controller, it searches for LDAP service records. When Kerberos authentication is required, it searches for Kerberos service records. When applications need to locate a global catalog server, they query global catalog service records. The Netlogon service running on each domain controller automatically registers these records. If DNS registration becomes corrupted or incomplete, administrators can often restore the records by restarting the Netlogon service or forcing DNS registration. Because Active Directory depends so heavily on DNS troubleshooting is often one of the first places administrators look when authentication or connectivity issues occur. A common saying among Active Directory professionals is simple. If Active Directory is broken, check DNS first. More often than not, that advice proves correct. Section 3. The Global Catalog. Next, let's examine the Global Catalog. The Global Catalog becomes especially important in environments that contain multiple domains within a single forest. A global catalog server stores a partial copy of every object from every domain in the forest. Notice the word partial. The global catalog does not store every attribute for every object. Instead, it stores a selected set of commonly searched attributes. This allows users and applications to perform forest-wide searches without requiring complete copies of every domain database. The global catalog serves several important purposes. Section 4. Active Description Replication. The final component we'll discuss is replication. Replication is what keeps all domain controllers synchronized. Unlike traditional systems that rely on a single writable server, Active Directory uses a multi-master replication model. This means that almost any domain controller can accept changes. When a change occurs, Active Directory automatically distributes that information to other domain controllers. Chapter Summary. Let's review the key concepts from this chapter. The NTDS.dit database stores all Active Directory information and serves as the foundation of the directory service. AD Integrated DNS allows clients to locate domain controllers and provides secure, replicated name resolution throughout the environment. The global catalog enables forest-wide searches, universal group lookups, and efficient cross-domain authentication. Replication ensures that changes made on one domain controller are distributed throughout the organization while maintaining consistency and reliability. Together, these components form the core infrastructure that keeps Active Directory operating smoothly. In the next chapter, we'll focus on domain controllers and FSMO roles, exploring the specialized roles that coordinate critical operations across the Active Directory forest. See you in Chapter 3.